Hi friends, welcome back. This video is associated with learning of logarithmic differentiation. This is very important as far as the JEE mains is concerned. Direct questions related to will be coming from basically this concept, and this is really very important. Once you learn this, it will just appear like it's so easy. But beginning, if I give you a question which you are not able to handle with some standard derivatives, this is going to help. And this is again one more rule to the rules which we have learned. And next two parts again will be related to this one only. Like we will be studying different types of differentiation which will be case specific. Let's begin with the part and explore what lies ahead. Now this is where the IIT-JEE stuff starts. Okay, till now, as already told, that we have been doing basics. Okay, for those who are like already quite comfortable with that, now the things will get start heating up. Okay, so logarithmic differentiation. Okay, now there are some cases where you will find that there is no rule. Actually, the rule is not existing for them. Okay, so like till now we have discussed about x raised to power a or x raised to power n raised to power x. Okay, in this case we took specific case e raised to power x. For this it was given. Okay, now what happens if ax is given, e raised to power x? The only difference is that you just do it in the same way, it remains same. The only thing, log a comes, base power e. In this comes, but log e is 1, so it does not appear in the formula. But okay, so even if you are doing for this, you have to differentiate the whatever is inside. Okay, and again we discussed for ln x also. So for ln x it was 1 by x. Again, when the base is not natural, okay, suppose it's log 10 x, so what you need to do, you will change it, convert it, log x ex over log 10 by the base change property. Okay, and then if you differentiate, you will just get it 1 by x, so log 10 will come along with it. Okay, so now logarithmic differentiation comes. Now suppose if I consider this case, now what will I do? Okay, so obviously for this we don't have any which rule will go first, for this or for this. Okay, so neither of them actually goes. Okay, so for those again, like we can obviously make them combination. The chain rule obviously we can think of, but logarithmic differentiation makes it very easy to solve such questions. Okay, so what do we do? Like in this it's said, okay, let me first rub off, clear up the things. Okay, so now it's readable. Yeah, so it says if u and v are functions of independent variable x, okay, and then to differentiate functions of this form. Okay, whenever there is function par function. Okay, till now what we have done, we discussed that, okay, u into v, u by v, u plus v, kind of u minus v. But what happens when u raised to power v is there? Okay, that's the perfect thing. We'll consider that. Okay, this thing. So now what do we say? Okay, y, let y be u raised to power v. Now if I take log makes my work very easy. What it does? It says v into log u. The property of log m raised to power n is equal to n log m. This is the property I am using. Okay, so for this again, now if I differentiate, I know this is 1 by y. Now again, make an important note here. This is a common mistake which I am telling right now. Now what is the difference when I am differentiating log y with respect to y and with respect to x? Okay, now when I do this, it will be 1 by y dy by dy, which appears to be 1. So we say 1 by y. Don't do it like this. Since we are differentiating with respect to x here, so it has to go like this. So this is 1 by y, no problem. But once you differentiate the inner part also, like I mentioned, like in the x it does not appear y because dx by dx is 1. Same goes for this thing. So log y, if I differentiate with respect to x, first I have to differentiate log with respect to x, that rule, and then again dy by dx. So same thing will go here, and this is very common mistake which students find it difficult. You should understand that when I am saying log x, it's directly the function of x. When I am saying log y and differentiate it with respect to x, then first I have to cater the x log function. Whatever the log is, that does not matter, okay, even if it's log anything, sin x. So what is my first requirement? That first I will differentiate log. Whatever is inside, I don't require that initially. But after that, we'll follow the chain rule, okay. So here it goes like this, then v, then log u, differentiation will be. Now these are the functions of x. So obviously once these are the functions of x, we don't need to worry for the that part, whether it's gonna be any other function, because if I consider x raised to power x, like in this case, okay, so it will be x log x. Now I know this is the function of x, okay, plus, so v dash into log u. This is how it goes, okay. So from here you can get dy by dx as, you just take y that side, okay. So let me clear the space, as we are gonna require some more space here. So I hope this is clear, that what difference this creates, okay. Otherwise it would have been very cumbersome if you go by first principle, or if you go by even chain rule. In this case it would be very cumbersome. So in order to avoid that thing, this is a perfect rule, okay. This you can again say it's a kind of rule when the functions are in that form, okay. So this is the example given. If x raised to power y is equal to dot y raised to power x is equal to 1, we have to find, okay, dy by dx, okay, that is missing here, that you can add. We have to find dy by dx, okay. So now in this case again you can see that this is even more interesting, isn't it? So either what we can do, either we can start with log, or what we can do, x raised to power y is equal to 1 upon y raised to power x, okay. This I can write it as x raised to power y is equal to y raised to power minus x. Now if I take log on both sides, what I'll get, y log x is equal to minus x log y, okay. Now this makes my work quite easier. Now if I differentiate on both sides with respect to x, what it becomes, so first function as it is, this is by x plus derivative of this thing into log x. Then here it goes first function as it is. Now derivative of this is interesting, you have to keep note of this, that this is 1 by y into y dash. Why? Because y is not x here, and this we are differentiating with respect to x. In the second one it will be differentiation of this, that will be minus 1 into log y, that is minus log y. Now you can club these terms together and rest of the terms together. So this gives you basically dy by dx. The important thing to note here is that you are not getting it independent of x, whatever dy by dx. So it's not necessary always that it will be explicitly in terms of x only. Sometimes what happens, you will be given y equal to fx, okay. Now obviously if I am asking you at x equal to 2, so corresponding to that you can find the y and put it in dy by dx. If dy by dx is a function of both x and y, it may be possible. So where do you get the y? If it's only x, then the point is given. If it's not only x, then you can find y from that part, okay. So let's look at some examples based on this, okay. Differentiate log x. Now again this is u raised to power v, okay, very simple. Y is equal to log x. Now here log x is already present, okay, so it will make our work, let's see, easier. Or so this goes like log y 10x log of log x, okay. So now if I basically differentiate it, it will be 1 by y dy by dx. Do not forget this, I am mentioning it again and again, this is a very common mistake. What we do, okay, when we are differentiating with respect to one variable, we have to keep in mind that whatever is we are doing, always, even if it's x, you can always write dx by dx. Ultimately it will become 1, okay. So you don't need to worry for that. First function as it is. Now log of log x, so first we are applying for this one, okay. So 1 by log x, this log we have solved, okay. Now we will be going for this log, so this will be 1 by x. Now x will be 1, dx by dx, okay. So this is solved. Plus log of log x, and I guess most of you must be knowing by now what is this. So this will be secant square x, derivative of tan x, okay. So now we can write dy by dx as y, which is equal to log x raised to power 10x, okay, into this thing, okay. And obviously this is separate, this is one term, okay. So I hope that this makes this was an easier example, okay. We'll consider one more example, okay. So it says y is equal to sin x plus cos x raised to power x. Then now you will find that each example, once you know the trick, as all of you must have noticed, the magic is only mesmerizing until you know the trick. Once you know the trick, it becomes quite normal, okay, or quite ordinary, okay. So same goes with this concept also. If at the beginning these kind of questions would have come, you would have just scratched your head at what to do, okay. Now you just simply know that what I need to do, 1 by y dy by dx, and then obviously x, we need to find dy by dx of this function, x log of whatever is there, okay. So this becomes again very easy. I'll do it. So first, if I keep it like this, so log of this will give me 1 upon sin x and plus cos x. Now if I differentiate again, this means again we need to consider that if I'm having this kind of thing, so first I differentiate according to log, which becomes this. Then I also need to differentiate this. Please remember this again and again. I am telling this, that when you are differentiating with log x, you are doing that step, but that step is not visible. Why? Because this is 1. But in any other case, if it's y, if it's z, you have to differentiate that variable with respect to x as a chain rule, okay. So this thing goes like this, and sin x is cos x is minus sin x, okay. Plus, now this goes 1, so log of sin x plus cos x, okay. So this becomes again very easy. You can just take the y on that side, okay. Okay, so let's do one more problem, interesting problem. I'll do it here only. I'll write the question here itself, and this thing just clicked to my mind, okay. So because these questions are becoming quite easy, so in that question I'll just clicked in my mind, okay. So it's something, it says like y is equal to 2 raised to power log 2 x raised to power 2x, okay, plus something of tan and pi by 4 x raised to power pi by 4 x. The question was something like this only, or there might be some change maybe here, okay. So we need to find dy by dx at x equal to 1, okay. Okay, so the question basically was, okay, 4 was here, yeah, now it looks fine, okay. Now this is very interesting, again not related to direct logarithmic, but this is just a miscellaneous problem. You can take it as a miscellaneous problem, okay, for your practice, okay. So now we should know this rule, that a raised to power log ab is nothing but b, okay. Those who are not clear with the log, again stop, first follow the log, then go for logarithmic differentiation again, okay. So you can just read the properties of log, which will be very helpful, okay. So this cancels out basically x raised to power 2x plus tan pi by 4 x raised to power. Now here this part will be requiring the logarithmic differentiation. This is clear. This part also again it's similar like x raised to power x, okay. So the only difference being 2x. So what I'll do first solve this, and then I'll solve this, okay. So this one is, it goes like this, y equal to x 2x log x. So the only difference is this 2 that will bring, okay, that it will 2 will be outside, rest inside, it's easy, 1 plus x log x. If I differentiate this, and 1 upon y dy by dx. So y will be x raised to power 2x. Okay, so that this is done. Okay, now going for this again, same thing will appear, 4 by pi x log 10 pi by 4x. So this is again, now this is bit tedious. Okay, it's not difficult, but it's bit tedious. So this is your log y. Again, if I say, okay, let me change the color so that the things, they are looking different. Okay, so now if I differentiate this, so 4 by pi I can keep outside, x I can keep as it is because the other one will be quite easy. Now this one, first I'll differentiate log. Okay, so for log, this is the input, so this is 1 upon 10 pi by 4 x. Okay, now for this one, it is secant square pi by 4x. Now the story does not stop here. Why? Because it's not x only, it's pi by, so if you are going to do for d pi by 4x over dx, it's not 1 anymore. Okay, it will be pi by 4 will come outside. So you have to keep in mind that when you are differentiating x with respect to x, and when you are differentiating kx with x, so you have to keep in mind that k has to come outside. So whatever is the coefficient of x, that has to come outside at the end. So this will be pi by 4 and dx by dx will be 1. The other part is easy, x will be 1 and this will be as it is. So this is a perfect example, again a bit more difficult problem with what we have discussed before this. So I guess this you should do once more fairly. I've done it roughly here, so you must go it for fairly and do it properly. Okay, so that's it for logarithmic differentiation, and this becomes very important part for the JEE. Also, you will find many where this concept as one important step of the question. It might not come as a question in JEE advanced. In mains, obviously it will come, but in advanced it will form a crucial part of your problem. This seems so easy now, logarithmic differentiation, isn't it? Yes. I hope it must be a yes from each of you. Okay, so in the coming parts we're going to start with more differentiations, more types of differentiation and more cases. Up till here we are like at the middle of our journey, and this is where, starting from this part only, where the JEE mains, JEE advanced journey starts. Stay tuned for the coming parts.